In the previous video, I told you about the arrays, SystemVerilog arrays. Like just it was a introduction part. So in this session, I will tell you the types of array and how can we classify the arrays. Okay. So we will see array classification. So there are two useful way to classify array in SystemVerilog. So first is based on dimension placement, or you can call this as uh, based on how how we declare the size. Okay, so in this case you have packed array and another is unpacked array. Now this one I just want to modify it. Okay, so another see, this is the first way of classification, that is based on dimension placement or based on how we declare the size. So in this case you have packed array and unpacked array. Apart from that, second ways using which you can classify, that is based on when storage is allocated. Storage means what? Storage means memory. So when memory is allocated, so you have two type, like you can allocate memory in two ways. First is during the compile time and second is during the runtime. So based on that uh, we will uh, classify our arrays. So in this case you have static array, dynamic array, associative array and queues. So these are the classification of based on when we allocate the memory. Okay, so in this case first we will start from packed array. So we will see here what is packed array. So packed array stores its element contiguously as one vector of bits. So this is nothing but vector in Verilog data type. It is similar to vector in Verilog data type. What is happening? It will store all the elements in a contiguous location. In a it's like only single location. So store element at a single location. Okay. The packed dimension is written before the variable name. This is the way to identify it is a packed array or it is unpacked array. So packed array means dimension. Dimension means size of the array. So yeah, it will be more clear. Size is written before the variable name. Variable means name means what? Variable name is nothing but array name. Array name. Okay. In this case, when you going to declare any packed kind of array, in this case you can declare you can use only res data type, bit data type or logic data type. You cannot use other SystemVerilog data types. So you have to be careful about this. Otherwise if you declare like this int of 3 down to 0 and then a, it is not correct. Okay, it is not correct. So you should not do like this. You have to use only these three data types, that is reg, bit and logic. Okay, you can directly perform all the operation. Okay, in this case, in this kind of packed kind of array, you don't need to use index. You can directly perform all the operations. All the operations means what? Addition, subtractions, and you have a modulo operation, division operation. All those operation you can perform directly. You don't need to use the index because of single location, because everything is stored at a single location. So you don't need to use the index. Okay, so what is the example? You see, this is an example. Logic 3 down to 0 and a. So in this case, see, this is the array name and this is the size. So when we are declaring the size before the array name, so that is why this is a packed. So this is a packed between, the size is packed between logic and a variable name. So it is a packed kind of array. Okay, now if you see how it is, like how you can imagine this, like how you can visualize this. So this is a way of visualization. So this is total size is how much, you know, right? 4. So this will be look like this. So this is a 4 bit of single location. This is at a single location you are storing a 4 bit, and this will be look like this: 0 1 2 3. It will look like this. Okay, we will see more example, then it will clear, and we will do some coding also, then you will get more clarity on this. So you can think of it as a one contiguous group of bits. So see here, one contiguous group of bits means what? See, this is at a location. This location we can store how many bits? Total 4 bits. So this is how you have to understand. Another example, if you see, we declare a logic 7 down to 0 data. So this data is a variable which can store what is the location of this? Only one location it can have. It can have only one location. Means it is a single element that can store total 8 bits. So 0 to 7. Okay, so this will be look like this.